Okay, so we'll start with a new topic, which is perspective drawing, perspective projection. So basically, it's like when you keep, it's a representation, and when you keep the object on a plane surface, um, which is um, which is called the perspective plane, and what it appears to the eyes when viewed from a fixed position is basically the perspective projection. So it can be defined in two parts, which is 1 point perspective and the other is 2 point perspective, uh, and even 3 point, 4 point, 5 point. But we'll be studying only 1 and 2 point perspective. So basically, what is principle of perspective projection? If the perspective projection, the eye is assumed to be at a definite position related to the object. The vertical plane, which is called the picture plane, is space between the object and the eye. Then the visual rays from the eye to the object converge to a point in the eye and are therefore inclined to the picture plane. The rays pierce the picture plane and form an image on it, and this image is the perspective of the object. Then there are a few elements which you will study in this perspective projection. First is the ground plane, which is called GP, and it's the horizontal plane on which the object is assumed to be situated. The second is station point, which will be marked as S. It is a point where the eye of the observer is located while viewing the object. And then there is a picture plane, PP, and it is the vertical transparent plane which is located between the station point and the object which is to be viewed. It is a plane on which the perspective is formed, and the front view of the perspective element and the object is also projected to this plane. Then comes the horizontal plane. This is an imaginary plane, it which is at the level of the eye from the station point. Uh, the horizontal plane above the ground plane and it makes a right angle to the picture plane. Then there is auxiliary ground plane, which is AGP. It is a horizontal plane placed above the horizon plane. The top view of the object and of the perspective element is projected on this plane. Okay. So if you all can see, this is your auxiliary plane. Then there is a ground line, the line of intersection of the picture plane with the ground plane is called the ground plane. So this one is your ground plane. Sorry, this one is your ground plane line, and this one is your ground plane. Then there is a horizon line, which is the line in which the horizon plane intersects the picture plane, and it's parallel to the ground line. So this one is your horizon line, and it's parallel to the ground line. Then the center of vision, it's a point. this is the point. If you can see, so it is a point in which the perpendicular axis bears the picture plane and is called the center of vision. It lies in the horizon line. Then there is a central plane. It is an imaginary vertical plane which passes through the station point in the center of vision. It also contains the perpendicular axis. It is perpendicular to both the picture plane and the ground plane. Okay, so we have, like you can see, this is the angle of vision. This is the horizontal angle of vision. The angle here is 45 and 60. The angle here is 60 degree, and when it comes to vertical vision, the angle is 45 over here. So there are basically two methods. First is the visual ray method, and the second is vanishing point method. So basically, there are like the types of perspectives we are learning is the first one is parallel perspective or one point perspective. The second is two-point perspective. So basically, what is one point perspective? When an object uh, has its one or more faces parallel to the picture plane, its perspective is called parallel perspective. And it also has one point perspective as an edge converges to a single vanishing point of the parallel faces. Same way, the angular perspective or two-point perspective is when the object has its two faces aligned to the picture plane, and then its perspective is called angular perspective. It has the edges of the object which converge to the vanishing point. So let's quickly see how can we make a one point perspective.
appears as if all the lines are vanishing. And the point where all the lines are vanishing is what is referred to as the vanishing point. Now, right now, you guys are watching this video on a mobile device, let's say, okay? At any instant of time, or let's say you are roaming around a park or somewhere else, at any moment of time, you see a picture, and a collection of pictures is basically a video. If you take a look at any picture, all of them will have a particular vanishing point. It will appear as if all the lines are converging to one single point. And that is something which we will be seeing in the upcoming demonstrations also. Just take a look at this. Now, these two tracks, not these two tracks, but these two rails are connected with the help of what is known as sleepers. Just take a look at this. Okay, this sleeper over here, this appears a bit larger in size than this one. If you keep this going, let me keep this going. The sleeper which is closest to you appears largest in size than the ones which are getting farther. What is this going on? We know that these two rails are absolutely parallel to each other. In reality, yes, they are absolutely parallel, but the farther we see, it appears as if both the rails are converging at a particular point, and even all the lines are converging to a particular point. Okay, and that point is what is referred to as a vanishing point. Something strange is happening. This is what we see in perspective. Perspective projection is very realistic sort of a drawing, and it is mostly used by architects and not by engineers, but still we have to learn this concept. Okay, let us take a look at one more illustration and you'll get to realize what the hell is happening. Let us take a look at this. Now, this over here is a very famous painting by a very famous man. This painting, the name of the painting is The Last Supper. And this was basically drawn in the year, if I'm not wrong, 500 years back, 1495. And it started in 1495 and it ended in 1498. By a very famous man, Leonardo da Vinci. Now, but the fascinating aspect of this very drawing lies in the concept of perspective. That means all the lines will converge to a particular point. How? Just take a look at this edge, then this edge. Okay, all of them will be converging at a particular point, and that is going to be the vanishing point. Just take a look at this. Very strange. That means Da Vinci knew, intentionally or unintentionally, the concept of perspective projection. And all these lines converge to the forehead of Lord Jesus. Very strange, very strange. Okay. My focus right now is on the constructional aspect of this very room or dining hall where this sort of congregation is taking place. Let me just show you once again. All of them seem to converge at one single point. Okay, so this particular technique, perspective projection, is nothing new. It has been used since ages. Take a look at one more demonstration. There are going to be two vanishing points over here, and this is also beautiful. And in the course of this video, not this video, but this video series, you'll get to learn how a particular object can be drawn in 2-point perspective and 3-point perspective. And in this video, I'll mostly talk about and demonstrate how a one perspective drawing of any object can be made. And after watching this video, I can guarantee you that you can follow any textbook and solve all the problems from 1-point perspective with absolute ease. So let's go further. Let's take a look at some more examples. Just take a look at this. Where do you expect the vanishing point to be? I expect the vanishing point to be here, somewhere here. Okay, all the lines are converging here. All the lines, all the edges are converging somewhere here. Here it is. Okay, somewhere here, approximately. So this over here is the vanishing point. Even the lines connecting the tiles, if you start making lines, all of them are going to end up somewhere here. So that is the vanishing point, and that is the beauty. So every picture has an individual vanishing point, you can say, and the collection of pictures is a video. Okay, so vanishing point keeps on changing depending on the picture. Just take one more example. Take a look at this. Okay, beautiful scenery, beautiful surroundings, trees, a park basically. So all these angles over here are converging right here, isn't it? Like this. Even the intersection of tiles, okay, the line at the intersection of two tiles, even if you start joining them, they'll end up at one single point, and that point is a vanishing point. And this is the entire idea behind a perspective projection. Let me give you some more intuition into perspective projection, and let's see one more example. Just take a look at the intersection of all these tiles, right? Let us go back. All these lines I'm talking about. And when you draw lines like this, they're going to converge at a particular point. Even if you try to draw lines through beams, they're going to converge over here. That means each and every picture has a vanishing point. Okay, so the realistic picture framed by your naked eye is actually very closely associated with, or very closely approximated with, a perspective projection. You can say that the kind of picture that you see through your naked eye is pretty much close to a perspective projection. Okay, let's see if we have some more examples. Yes. Okay, it looks like a beautiful place. So what I'm going to do is just take a look. This edge and this edge, all of them are on the same height from the ground, and they are converging. All of them are converging at a particular point. This is that particular point. Then this is going to be the vanishing point. Let me show you why. And a line from here also, if you draw, all of them are going to converge at a particular point. So it is not necessary that the vanishing point is going to be right at the center of the image. It could be anyway. Depends on how the photograph has been taken, how it has been viewed, how it has been observed. Here it is. That's the vanishing point. Everything that you see through your naked eye is a perspective projection, approximately a perspective projection, and it is going to obviously have a vanishing point always. So now let us talk about the principles of perspective projection, and here it is. Number one thing, it is the most realistic form of projection. Yes, as I've already said to you, that the kind of image that your eye forms is pretty much close to perspective projection. Okay, this is exactly what I have written. It pretty much approximates the results obtained by the human eye. Now, the one thing which is very important is that it is of very important to an architect. Okay, but each and every engineer should understand the basic principles behind the perspective projection. Right now, if you're an architect, you need to show how a building would look from inside, in reality how it would look, and in that case you need to take help of this perspective projection. Okay, why? Because it is the most realistic form of projection. So instead of showing its true shape and size, it is rarely used by engineers, and engineers basically follow the orthographic projection. Why? Because the true shape and size of the object can be observed. That's why we are basically interested in orthographic projection. But as an architect, they use or perspective projection, and as an engineer, we actually go for an orthographic projection. But it is very, very important to learn both the kinds of projection system. One is very realistic, this perspective projection, and while the other, that is orthographic projection, shows you any object in its true shape and size. Some more points which are extremely essential. Just go ahead and read this, and rather I would like to explain these 2 points with the help of an illustration. So here it is. Okay, so what we got here is an object. Okay, and then I'll obviously have a plane of projection into which the image of this object is going to be obtained, and then I'll also have an observer somewhere here. This yellow dot over here is an observer. right? Or a station point. So in the environment of perspective projection, the observer is referred to as a station point. So what will happen? One thing you know very well, that the rays of sight, okay, something which I call as visual rays, they actually converge, okay, converge where? They are going to converge to the station point. So there are four corners, one, two, three, four, and all of them rays of sight, visual rays are going to converge at one single station point, like here. And in this process, they are going to penetrate and pierce this plane of projection at 4 points. Let me show you exactly where. This one, this one, this one, and this one. When you join all these points in proper sequence, what do you have? You have an image. And let me just go back slightly. When you join all these 4 points, what do you have? You have an image. And this is, in layman terms, you can call it as an image, but in the environment of perspective projection, and this is what you refer to as a perspective. Hope I'm clear. Okay, always remember, the in orthographic projection, the rays of sight, okay, rays of sight are parallel. That is why it falls in the category of parallel projection. Whereas in perspective projection, the rays of sight or visual rays are sort of a converging at station point. Always remember, this is one thing which differentiates orthographic from perspective. Okay, now let's get a bit more technical and let's learn the elements of perspective projection with the help of this beautiful illustration. So these are the 10 important terms with respect to a perspective projection. So let us take a look at all of them one by one. Here it is. This over here, this yellow colored plane that you see is the ground plane. Remember this. Okay, it is a horizontal plane on which the object is assumed to be located. Fine. Secondly, this is the observer, and the eye of the observer is what is referred to as a station point. Eye of the observer is what is referred to as the station point. Fine. Thirdly, we will have a picture plane onto which the image is going to be formed. Okay. The plane which was pierced in the previous slide that you saw, over there we named it as plane of projection, but here to get more technical, we'll call it as picture plane, and it is actually perpendicular like this. This is the picture plane, vertical transparent plane where the perspective is formed and lies between the object and station point. So the object is going to be somewhere behind the picture plane, and between the object and the station point we'll have the picture plane, and it is intended for front view projection. Well, obviously it's a front view projection. We are watching it from here, from the front, and not from the top. Then one more plane which is very important. It's the horizontal plane, or some people also call it as horizon plane. Here it is, right from the eye level. Okay, the plane from starting from the eye level and absolutely horizontal to the ground plane is the plane of horizon or horizon plane, and imaginary plane at the eye level is the horizon plane. So 4 important terms we have discussed. Let's take a look at the 5th one. This is the auxiliary ground plane. Here it is. It is parallel to the ground and is intended for top view projection. So this is the plane where the top view is projected, you can see. And here always remember guys, we are going to be using the third angle projection method. Okay, third angle projection method. The concept of third angle projection method is going to be used, remember that. And here the top view is above and the front view is below. Okay, this is something that we'll be applying. Don't worry, everything will fall in place. Even if you don't
So we have studied in orthographic projection as well, in which we have studied that we work in the third angle projection only, in which you have your top view and then you have your front view below it.
know third angle projection method, you can still work with it, no problem. Okay, but you've got to watch this video right till the end. Something more on this is also done. We've got the ground line. This is the ground line. Intersection of picture plane with the ground plane will give you the ground line. Okay, line of intersection of picture plane with ground plane. Done. So next up is horizontal line. Okay, this is the horizontal line. Let me just show you. Intersection of what? Intersection of picture plane with this pink colored plane, that is the horizon plane, is the ground line. Absolutely simple. Not the ground line, but the horizon line. Okay. Then we've got the perpendicular axis. So you are right here. This is your eye, right? And it's going to be something like this. So this axis you see, this is the perpendicular axis. Okay, something like this. Now this is the line drawing through the station point and is perpendicular to the picture plane. Obviously it is perpendicular. If I were to draw a line like this, an angle like this would be made perpendicular to the picture plane. Okay, very simple. Finally, two more points. One is center of vision. So if you watch here carefully, guys, this let me just erase this slightly. This over here, this intersection, this is what is referred to as center of vision. It is the point where the perpendicular axis pierces the picture plane. And then finally we have this. This is, let me just show that once again. This is what we call the central plane. Okay, this is the central plane. It contains the perpendicular axis. Well, it really does. And it passes through the station point and center of vision. This is the center of vision and this is the station point. So central plane is basically a plane which passes through the center of vision C and station point SP, and also it contains the perpendicular axis. Done. So these are all the elements of perspective projections. And if you are preparing for some competitive examinations like engineering services and all other examinations which have engineering drawing as the subject, this is going to be very helpful because questions directly regarding all these terms are asked. Okay, definition will be given to you and you need to identify from all the 4 or 5 options which one is the correct element of that perspective projection. So this is how questions are asked, right? Now let's get started with some real stuff. Here it is. Okay, so we are going to kick off today's session with parallel perspective. There are 3 types of perspective: 1 vanishing point, 2 vanishing point, and 3 vanishing point, or also known as 1 point perspective, 2 point, and 3 point perspective. And in this video, I'm going to specifically talk about 1 point perspective, which is also known as parallel perspective. 2 point perspective is known as what you call angular perspective. Okay, and 3 point perspective is what we know as the oblique perspective. So just read this definition. Now let me make it very clear. So you've got the picture plane, you have got the ground plane. Remember, picture plane and the ground plane. Now if one face or more than one face of the object is actually parallel to the picture plane, then the sort of perspective that you're going to make is going to be a parallel perspective, and you'll always get one single vanishing point.
Akriti, watch this very carefully, and in the next class we'll be drafting this.
Okay, that is a 1 point perspective. All the edges are going to converge towards that vanishing point. How to deal with that? Let's see. Okay, so let's just read this problem, and this is going to be very intuitive to understand the concept of parallel perspective. So I've basically taken 3 cases. In the university examination, you will be asked only 1 case. Nobody is going to ask you 3 cases, and even if they do, you know what the deal is. Okay, so here we go. Draw the 1 point perspective of a box of dimensions 40 by 70 by 50. Length by breadth by height. The station point 70 mm away from the picture plane. Okay, so in the top view, this distance can be seen 70 mm away from the picture plane and 90 mm above the ground. So in the front view, the station point, the level of eyesight, the eyesight will appear at a height of how much? 90 millimeters. Okay, from the ground. Now first of all, we need to make 3 different drawings. One for this, station point 100 mm towards the left of axis. Second case, station point right in front of the line, with right in front and in line with the axis. And the third case is station point 100 mm towards the right of the axis. So we'll be dealing with each and every case, don't worry. Let me just give you as to how the object has been placed with respect to the picture plane and the ground plane. Let's take a look at this initially, and then we can obviously make the drawing, no problem. Everything will fall in place. Here it is. So ground plane, picture plane, you know this, okay? This over here is obviously the ground line, which can be seen from the front. The picture plane appears as a line. This line will be seen from the top view. So the picture plane appears as a line from the top, whereas the ground plane appears as a line from the front. Remember, what are we going to follow? We are going to follow the third angle projection system. Okay, the idea of third angle projection system. Top view above and front view below. Right? So let's kick off. There is an object. One face of that object, if you see here, this, and let me just write this properly. Guys, this is going to be 40. This is 50. And this length is 70. 40, 50 and 70. And one of the faces, you can clearly see, if you have to make a 1 point perspective, you've got to keep one face parallel. If this is given in the question, if one face is parallel and you have been said to make the perspective projection, then obviously you have to go for 1 point perspective. Okay. And if any one face is inclined, then obviously you have to go for a 2 point perspective. You'll see that in the next video. Right now, let's focus on this. So what we've basically done is, we've kept this face. This is something that we've assumed, 40 by 50 face, okay, to be parallel to picture plane. This is not profile plane, by the way, this is picture plane. And it is actually sticking or in contact, you can say, with picture plane. If it is in contact or at a certain distance away, it will still remain parallel. Okay. Anyway, so this is how it has been arranged. Right. So what is this? What is this? The station point is 70 mm away from the picture plane. So guys, this distance over here, this distance I am talking about, this is nothing but 70 millimeters. And somewhere here along this line, we'll have the station point. Let me just show you. It is 90 millimeters above the ground. Okay, 70 millimeters away and 90 millimeters above the ground. Here it is. Let me just show you. There you go. This over here. This is how much? This is 90 millimeters above the ground. Now again, there are going to be three positions. Second, and this is the third position. First, if you take this central axis, this distance initially, how much towards the left? Station point 100 millimeters to the left of the axis. So this is going to be 100 millimeters. Secondly, station point right in front and in line, right in front, okay, and in line with the axis. So this is going to be station point 1, this is going to be station point 2, and this is station point 3, which is 100 mm towards the right of the central axis. Not here, but it's going to end up somewhere here. This is 100 millimeters. So this is basically the arrangement with which, or following which, you have to make the perspective. 1 point perspective basically. How can this be accomplished? So first of all, you need to make the layout, okay? And just try to understand this. This is very important. If you can understand the layout, then drawing, it's a very easy deal. Here it is. So first of all, let me make the what? Below, what are we going to make? We are going to make the front view. And in the front view, this ground plane appears as a line. So this is GL, okay, a ground line. Secondly, let's have this. We know how high this is. How high? Well, this is 90 millimeters, okay, and we'll obviously see this object. You will see this object. This is 40 and this is 50. So this is 40 and this is 50. Let me just mark it. No problem. 40 and that's 50. Front view. What is this? This is HL. This horizon plane appears as a line from the front, isn't it? Okay. So what is this line? This is the horizon line. What is this line? This is the ground line. Anyway, so that is done. Now, convenient distance. There should be some convenient distance, random distance. Okay. What do you need to make? You need to make this. PP. This is the picture plane. Now what we are making is the top view. Okay. So now we are watching this from the top. In the top, you will see this. The picture plane will appear as a line. At any convenient distance, just draw a line. Okay. It should be parallel to this HL, obviously. Behind this picture plane, you are going to see this. Please see where the mouse is hovering. This portion is going to be observed. So this is 70 and this is 40. That's it. This is 70, not this one, but this is 40 and this over here is 70. This is the top view. Now we know how high the observer is, how high the station point it is, right? This is 90 millimeters. We know this very well. But how far it is from the picture plane, that is something we can assess. It's 70. The station point is 70 millimeters away from the picture plane. If it is 70 millimeters away from the picture plane, then that distance can be seen from the top, in the top. So from the picture plane here, 70 millimeters away, what we need to do? We need to make a line. So this is 70 millimeters, right? And this is where the station point's top view is going to be. Okay. And this is where the station point's front view is going to be. So it's going to be, the first case is going to be here. This distance, you know that very well, this is going to be 100. Second station point, and this is the third station point. And for all the three cases, we need to make the perspective, primarily the 1 point perspective. How can that be accomplished? Let's see. So this is the layout which initially you need to make on a plain sheet of paper. Now I would suggest you guys to do this on a drawing sheet or on a drawing copy along with me simultaneously. So by the time the video ends, your drawing will also finish. It's going to be very, very easy. Okay, trust me. Let's kick off. So this is the top view. This is the top view of the station points, top view, and this over here are the corresponding front views of the station points. That's it. Here we go. First case. Let me show that once again. This is the observer or the station point, 100 mm towards the left. Now this distance is 100 millimeters. Okay. So let's kick off by the ground line. Let's make the object. This is going to be 40, that's 50. This is going to be the perfect drawing. And then this HL, you can just extend this. This is the horizon line. How much high? This is 90 millimeters high. We know that. How much far this distance is? Well, this is 70. We know that. So this is the front view initially. So from the ground line, it will appear as if there is this line 90 millimeters above. That's it. 90 millimeters above. What's next? Okay, at any convenient distance. This distance could be anything. And finally, I will make a comment on how much distance you should take. Don't worry, everything will fall in place automatically. Now let's make the top view. In the top view, you'll see this distance, that is 40, and this is 70. Let us do that. 40 by 70. Okay, absolutely in line. Absolutely in line. Okay, start to finish in line. There you go. Now the station point is how much away? 70 millimeters away, and this can only be seen from the top. So in the top view, we are making this 70 millimeters away. We have made this line, and somewhere here we'll have the station point's top view. So SP1, this is going to be SP1, station point 1. Okay, how far from here? The distance is going to be 100 millimeters. So SP1, this is the station point 1 in the top, and its corresponding front view is going to be somewhere here. Okay, you can call it vanishing point also, or you can call it the front view of the station point. It absolutely depends on you. Okay, but most of the books you'll find this to be written as vanishing point. So I've written it as SP1 dash because there has to be much more clarity in the drawing. That's why. Only reason being that. Okay, so and in the upcoming problems you can just replace this SP1 dash by VP. Your choice. Now what to do? This is the front face, this is the back face. This over here, this front face is in contact with the picture plane, that can be seen clearly, and this is the back face, 40 by 50 face. Now this front face is shown in its true shape and size, no problem, because it is sticking to the picture plane, that is why. But as you go further away, this sort of will reduce. Okay, and how to make that assessment? Because we are watching this from over here, from the left slightly, so it would appear to us something like this. This this will get narrower and it will appear as if it is this much. So the face which is 40 in reality will appear as if it is only this much in perspective. Let me just erase this. So let us just focus on drawing. Now, top view done. We are watching it from here. Okay, this is the top view, and for making the corresponding front view, how would it appear in perspective? What you need to do is watch this. All the points 1, 2, 3, 4, all the points have to be connected with this vanishing point. Okay, and before that, you need to bring all of these points over here. Fine, and then just connect them with the vanishing points, all these 4 corners, and here it is. Let me just mark them. Let's say this is A, B, C, and D. It will be much better. This is the front view, isn't it? This is going to be A dash, B dash, C dash, and D dash. That's A, B, C, and D, isn't it? In the top view, A, and below A it is D, and below B it is C, below B it is C. So we are basically focusing on the points behind. The points behind are E, F, and there is going to be a point somewhere here, G, and H. It's like this: E, F, and below F there is G, and below E there is H. Okay, so below behind A there is going to be E, F, and this is going to be what? C, G, and this has got to be H. No, we can actually obtain these points. Let me just show you where these points can be obtained, and you can understand this pretty well. Okay, so the points behind are somewhere along this line, somewhere along this line. Okay, this is the face behind, and this face will get narrower. On the picture plane, it will get narrower, right? Okay, so these are the lines. The back portion is something of this sort. This over here behind A, what is there? Point E. This is going to be for E. E dash. Okay. Then this D, behind D, what is there? H. So this is going to be H dash. Right? Now, towards the right of E, what is there? There is F. So E, F, and this has got to be G. Now, this portion has been made with the help of hidden lines. Okay. So as it falls absolutely below a face, that is why. So this is how the perspective of a block rather can be made when it is viewed slightly from the left. Now, in the next slide, I'll show you how does it look when you observe it right from the front. Okay, how does it look? Now, this top portion, this top face is also visible. Why? Because the eye level is higher than the maximum height. The maximum height is how much? This is 50, and your eye level is 90 millimeters. That is why this top face is visible, although in perspective. Okay. Just don't worry. Watch one more example, second one, and everything will fall in place. Just watch this. Now we are here. Let me just show that once again. Let me show that once again. The perspective will shift slightly as the observer is shifting right at the center. How to do this? Okay. No nomenclature, nothing of that sort. You can do that. What I'll try to do is, first of all, let me mark the station point. Station point 2. Okay. And this is the corresponding vanishing point. Right? We just show that once again. Station point 2. This is the back face. Okay. E, F, G, H. So it gets narrower. So the back faces, what do you say? Width will appear this much in the perspective view. Let me just bring lines, vertical lines from these 2 points down below. And let me just draw lines from all the 4 corners until you join it with this top or the front view of the station point, like this. Okay, so these are the points which I am interested in. Back face. These are the points. So when you join them, this is what you will get. So some of the edges are not visible. So they have to be shown respect in the form of hidden lines. That's it. So this is the entire idea. Right? Okay, let's see one more example. The third case, which said that the station point was 100 millimeters towards the right of the central axis. Here it is. Let's take a look at this case. Let me just show it to you once again. This is going to shift. Here we go. Okay. Now the station point is somewhere here, 100 millimeters, done. Now the back face, join it with this station point. Okay, this is the top view, by the way, and this is the vanishing point or the front view of the station point, whatever, right? Oblique VP you can write. Done. So when these visual rays are piercing the picture plane, this width gets narrowed. Okay, the image that you are going to see, it will appear as if the back face is not this but this one. Okay, so this has to be projected downwards. Done. Now join all these 4 points towards this vanishing point. Okay, this is the front view, by the way, all the 4 points, and in that process it will intersect the back face. So these are the 4 points that I'm interested in. Join them. That is going to be your final view. There you go. And now in order to give some respect to the edges which are not visible directly, they have to be drawn with the help of hidden lines. So that's it, guys. This is exactly how you can draw any object in one perspective. You just need to know where the eye level is, how far the eye is from the picture plane, and how high the eyesight is from the ground plane. If you know all these data, then you can easily frame or draw the perspective for any given object. I'm pretty much sure that after watching this video this way through, you can go ahead and pick up any textbook of engineering drawing and solve, or rather draw all the problems. Now the textbook that I would suggest to you guys is the one by N.D. Bhatt, Engineering Drawing. You can also go
So you have seen how to make edges. Now what we'll be doing? Okay, so I'll be giving you some questions in the next class. Till then, study once again what are the terms, what are the elements we have studied today, um, and go through this video again. I have already provided you the link in the study material under your class tab. Plus, you can also see this video, the class recording as well on the channel. And in the next class, we'll be working on the 1 point perspective itself. When we are done with at least 5 questions on perspective, then we'll switch to 2 point perspective. So for next class, I want you people to have your parallel bar, set square, all your stationery with you, so that we can directly start with the questions and this drafting part. Thank you for today.